Hi everyone. This is a help video following up from live class today where we talked about scale factor. I was receiving some follow-up questions about what we covered, so I wanted to create this video so you guys had a better understanding, an additional resource to use to help you to better understand scale factor. So when we talk about scale factor, we are talking about the relationship between two shapes that are the same shape but one size is a larger or a smaller version. So the two main things that we discussed today when talking about scale factor are the words reduction and the word enlargement. And reduction and enlargement are two examples of scale factor. So what we're going to do is we're going to talk about examples of a reduction scale factor, examples of an enlargement scale factor, and some key things to look for in both. So that way you know exactly what to look for when solving for scale factor yourself. So the first thing that we're going to talk about is reduction. Now, if something is reduced, then we know that it goes from a large object to a small object. So that is an example of a reduction. Again, something that is going from a larger shape to something that is smaller. So something that is shrinking in size. When we talk about reduction in terms of scale factor, the scale factor is going to be somewhere between the numbers 0 and 1. And let's talk about why that happens. If we wanted to keep two shapes the exact same dimension, so let's pretend for an example that we've got a square and this square has side lengths of 4 and 4. If we wanted to create another square with the exact same dimensions, then we would multiply both of those sides by 1. Because in order to maintain the same dimensions, you have to multiply by 1. If we multiplied by 0, then the side lengths would then fail to exist. So in order for something to shrink, though, we have to multiply it by something smaller than 1. Now, some examples of numbers that are smaller than 1 would be any proper fraction. So some examples of common proper fractions that we see are 1/2, 1/4, 1/3, 2/5, right? Anything where the numerator is smaller than the denominator. Because if the numerator is smaller than the denominator, that means the fraction is less than 1. It's not quite a whole. So those are examples of some scale factors. Scale factor can also, in reduction, could also be in decimal form. So again, we're looking for decimals that fall in between 0 and 1. Some common examples could be 0.5, 0.25, 0.6, 0.1. All of those are examples of decimals that are in between 0 and 1. So those are examples of reduction. Again, reduction is starting big, going small. The scale factor is always going to be in between 1 or 0 and 1. Now let's talk about enlargement. So enlargement occurs when we have a shape that was originally smaller and actually grew in size. So as we can see here in this example, our rectangle was small and it became bigger. So it was enlarged, the shape grew. When we're talking about scale factor and enlargement, that scale factor is going to be a number greater than 1. So again, reduction has a scale factor between 0 and 1. Enlargement is a number that is greater than 1. So examples of numbers that are greater than 1. It could be anything, really. It could be 2, it could be 3, it could be 2.5, right? It could be 7/2. Anything that is greater than the number 1 could potentially be a scale factor. Now, the reason why we talk about the range of numbers that are appropriate is because it's important for us to check our work when we're looking at reduction and enlargement. There is a common mistake that people make when they are working with scale factor, and that is that they do not properly use the formula. So what we're going to do now is we are going to discuss the formula for scale factor. And I'm going to show you a few examples of scale factor. And I'm just making these up on the fly. So these may look similar to ones that you saw in class today. They may look very different. Again, I'm just kind of showing you some examples off the top of my head. So let's go ahead and look at this one. The first thing we want to do when we're looking at a scale factor problem is we want to classify it with those two words that we used earlier. Again, those two words were reduction or enlargement. So what kind of scale factor is this? Well, we started with a small rectangle and we went to a bigger rectangle. So this can be classified as enlargement. So we know that this is a scale factor of enlargement, and we know that when we're dealing with enlargement, that means our scale factor has to be a number that is greater than 1. So now that we've established what we're looking for with our scale factor, let's actually solve for the scale factor. Now, say this shape has dimensions of 4 by 2, and say this shape has dimensions of 12 by 6. What we need to do is we need to create a fraction using our formula. So let's talk about that formula. The formula, there's a few different ways you might see it used. We went over both of them in class. The first one could be figure 2 divided by figure 1. That's a common one that you could see. So figure 2 divided by figure 1. Another one that you might see is new shape divided by old shape. That's another example that you might see. Trying to get back to my pen tool. And another one that you might see would be second image divided by first image. So those are some examples of some formulas that you might see. They all mean the same thing. Figure 2 divided by figure 1, or new shape divided by old shape, or second image divided by first image. All of these mean the same thing. We are looking first at the shape that is the new shape, or the second image. Sometimes is referred to as the copied image. That's the shape we're looking at first. We want to find the dimensions. So the dimensions are 6 by 12. And now we can look at the old shape. The dimensions are 2 by 4. We need to set up our fraction to follow the dimensions in these two shapes. However, we want to be very careful. Often people make a mistake and they just divide whatever they see. We have to make sure we're following the formula. We need to make sure we are dividing always this second image divided by the first image. So we can use corresponding sides. There's two sets of fractions that we could set up here. The first one will be 6 divided by 2, comparing the two heights, or we could compare the two widths, 12 divided by 4. Either way, when simplified, 6 divided by 2 or 12 divided by 4, these both simplify down to 3. So these two rectangles have a scale factor of times 3. That's an example of enlargement. Now, what we're going to do is we're going to use the same formulas, but now we're going to look at an example of reduction. So again, my formula does not change. I'm using the same exact formula, but this time we're going to pretend that this image was reduced. So we're going to say same shape, 12 by 6, 4 by 2, but this time our shape has reduced in size. Let's see how that changes the scale factor. This is where people make the biggest mistake. Our natural inclination when we're dividing is to always divide the bigger number by the smaller number. However, when we're dealing with scale factor, do you remember what we just talked about with reduction? When we are calculating reduction, the scale factor has to be in between 0 and 1. So we have to use the formulas that we have posted. They say the same. Figure 2 divided by figure 1. I have two different fractions I could set up for that. I can either put 4 over 12 or 2 over 6. Both of these simplify to 1/3. But you'll notice how my scale factor of 1/3, does that fit within the boundaries of what a scale factor for reduction can be? Is the number 1/3 a number that's in the range of 0 to 1? It is in that range. So that's why the scale factor works in this situation, because we checked our work and we verified that that is a number that works within the range of a reduction. So now that we've established how to solve these problems, what the difference looks like in scale factor, if it's an enlargement or a reduction, I'm going to do a few more example problems, and then hopefully that will be enough for you to better understand this concept. So we're going to be using those same formulas, always taking the second image and dividing it by the first image. So let's say we've got 2 diamonds here, and this one has a height of 20, and this one has a height of 4. I'm using my same formula. The second image divided by the first image. So I can set up my fraction as 20 divided by 4, which simplifies down to 5. Now this is an enlargement. My shape got bigger, so it makes sense that my scale factor would be a number greater than 1, because if it's greater than 1, then that forces the shape to grow in size. Let's look at another example. Let's say we have rectangle 1, rectangle 2. Let's say my dimensions are 6 and 24. I'm looking at my formula. Again, I'm always taking my second image. In this case, the dimension of my second image is 6. That's my numerator. And dividing it by the dimension for my first image, which is 24. 6 divided by 24. You could either use your calculator to convert that into a decimal. So 6 divided by 24 is 0.25. Or you could have just simplified that fraction, 1 over 4. Either way, both of these numbers, 0.25 or 1/4, those are equivalent, and they both fall in between the range of 0 to 1. So our answer, our solution makes sense. This was a reduction, so we know that this first rectangle, the dimensions had to be multiplied by 1/4 in order to shrink down and create that second image. And I'll do 2 more. Let's say we have 2 diamonds. My measurement for diamond 1 is 10. For diamond 2, it's 100. Using my same formula, second image, 100. divided by first image, 10. 100 divided by 10 is 10. So I know that my first diamond was multiplied by 10 in order to give me the dimensions for my second diamond. And one more example, large diamond, small diamond. Let's say that my measurement for this one was 75 and 25. My first image has a measurement of 25 divided by my second image has a measurement of 75. So again, I can either calculate that by dividing it into decimal form, or I can simplify the fraction. That would give me 1/3 or 0.3 repeating. Both of these answers are in between 0 and 1, so that is a reduction. So I did a few examples just to review skill factor, so everyone's on the same page. Again, a shape that starts small and gets bigger is an enlargement. So for something to enlarge, it has to be multiplied by a number greater than 1. If something starts big and gets smaller, that's a reduction. So the shape shrunk. In order for a shape to shrink, it has to be multiplied by a number between 0 and 1 in order for that shape to get smaller. When we're calculating skill factor, we always take the dimension of the second image and divide it by the corresponding dimension of the first image. So I hope this helps, and I'll see you in whole group on Wednesday. Thanks, guys.